Hello everyone, today it is lecture 5. We will discuss today DA converter, DA converter's operation and specifications, ISA PCI, AGP, PS2, USB interface, embedded communication systems, and embedded computer security. DA converter or DAC converts digital signals into analog format. An analog to digital converter performs the reverse function. So what are the basic operations of a DA converter? A DA converter takes a precise number and converts it into a physical quantity such as voltage or pressure. These converters are often used to convert finite precision time series data to a continuously varying physical signal. Generally, an ideal DA converter takes abstract numbers from a sequence of impulses that are then processed by using a form of interpolation to fill in data between impulses. A conventional DA converter puts the numbers into a piecewise constant function made up of a sequence of rectangular functions that are modeled with the zero order hold. Furthermore, DA converters generate thermal noise and are available with wide range of specifications specified by the manufacturers. Some of the important specifications are resolution, accuracy, linearity, monotonicity, conversion time, settling time, and stability. Resolution is defined as a number of different analog output voltage levels that can be provided by a DA converter. Absolute absolute accuracy is the maximum derivation between the actual converter output and the ideal converter output. The ideal converter is the one which does not suffer from any problem. Linearity error is the maximum derivation in step size from the ideal step size. An ideal DA converter produces equal increments or step sizes at output for every change in equal increments of binary input. A digital to analog converter is said to be monotonic if the analog output increases for an increase in digital input. Monotonic characteristics is essential for control applications. Otherwise, it would lead to oscillations. Settling time is the time between the start and the end of conversion. It indicates the speed of conversion. A typical settling time ranges from 100 nanosecond to 10 microsecond, depending on the word length and the type of circuit used. The ability of a DA to produce a stable output all the time is called stability. The performance of a converter changes with drift in temperature, aging, or power supply variations. So, all the parameters such as offset gain, linearity error, and monotonicity may change from the values specified in the datasheet. Temperature sensitivity defines the stability of a DA converter. Industry Standard Architecture or ISA is the 16-bit internal bus of IBM PC-80 and similar computers based on the Intel 80286 and its immediate successors during the 1980s. The bus was backward well suited with the 8-bit bus of the 8088 based IBM PC, including the IBM PC XT as well as the IBM PC compatibilities. The 16-bit ISA bus was also used with 32-bit processor for several years. An attempt to extend it to 32 bits called Extended Industry Standard Architecture, that is EISA, was not very successful. Even though ISA disappeared from computer desktops many years ago. But it is still used in industrial computers where certain specialized expansion cards never transition to peripheral component interconnect, that is PCI and PCI Express are used. There still is an existing user base with old computers, so some ISA cards are still manufactured, such as with USB ports or complete single port computers based on modern processor, USB 3.0 and SATA. PCI means Peripheral Component Interconnect. PCI is a local computer bus for attaching hardware devices in a computer and is part of the PCI local bus standard. The PCI bus supports the functions found on a processor bus but in a standardized format that is independent for any particular processor's native bus. Devices connected to the PCI bus appear to a bus master to be connected directly to its own bus and are assigned address in the processor's address space. It is a parallel bus synchronous to a single bus clock. Attached devices can make either the form of an integrated circuit fitted onto the motherboard itself, that is called a planar device in the PCI specification, or an expansion card that fits into a slot. The PCI local bus was first implemented in IBM PC compatibilities where it displaced the combination of several slow industry standard architecture slots and one fast local bus slot as the bus configuration. Configuration address space gives the PCI its plug and play capability. It has subsequently been adopted for other computer types. Typical PCI cards used in computers include network cards, sound card, modem, extra ports such as USB or serial, TV tuner cards, and disk controllers. AGP or Accelerated Graphics Port was designed as a high-speed point-to-point channel for attaching a video card to a computer system, primarily to assist in the acceleration of 3D computer graphics. It was originally designed as a successor to PCI type connections for video cards. Since 2004, AGP has been progressively phased out in favor of PCI Express, but by mid-2008, PCI Express cards dominated the market and only few AGP models were available only, with graphics processing unit manufacturers and add-in board partners eventually dropping support for the interface in favor of PCI Express. The primary advantage of AGP over PCI is that it provides a dedicated pathway between the slot and the processor rather than sharing the PCI bus. In addition to a lack of argument for the bus, direct connection allows for higher clock speeds. The second major change is that AGP uses split transactions where the address and data phase of a PCI transaction are separated. The card may send many address phases and the host process them in order. This avoids long delays with the burst idle during read operations. Thirdly, PCI bus handshaking is simplified. Unlike PCI bus transactions, whole length is Unlike PCI bus transactions, whole length is negotiated on a cycle-by-cycle basis using the frame and stop signals, and AZP transfers are always a multiple of 8 bits long, and the total length is included in the request. PS2 is Personal System 2. The PS2 port is a 6-pin mini DIN connector used for connecting keyboards and mouse in a computer system. Its name comes from the IBM Personal System 2 series of personal computers with which it was introduced in 1987. The PS2 keyboard port is electrically and logically identical to the IBM ATA keyboard port, differing only in the type of electrical connector used. The PS2 platform introduced a second port with the same design as the keyboard port for use to connect a mouse. Thus, the PS2 style keyboard and mouse interfaces are electronically similar and employ the same communication protocol. PS2 ports PS2 ports continue to be included so many computer motherboards and are favored by some users because PS2 ports may be favored for securing reasons in a corporate environment, as they allow USB ports to be totally disabled, preventing the connection of any USB removable disk and malicious USB devices. Secondly, the PS2 interface provides no restriction on key rollover, although USB keyboards have no such transition either, unless operated in boot mode, which is the exception. Thirdly, to free USB ports for other uses like removable USB devices is the another reason. And lastly, some USB keyboards may not be able to operate in BIOS on certain motherboards due to driver issues or lack of support. The PS2 interface has near universal compatibility with BIOS. Older PS2 only peripherals can be connected to a USB port via an active converter, which generally provides a pair of PS2 ports at the cost of one USB port on the host computer. Abbreviation of USB is Universal Serial Bus, which is a plug-and-play interface. This interface allows a computer or smartphone as well as other devices such as Mac PC to communicate with peripherals and other devices. When an USB device is first connected to an USB host, it starts the USB device polling process, which starts sending a reset signal to the USB device. The data rate of the device is detected. If the device is supported by the device drivers are loaded, and if it is successful, the USB device can be used. One of the things that have made USB cables so prevalent in the fact that they have two power conductors, which makes it possible to charge a device while it is plugged into a computer. USB offers three key advantages to peripheral manufacturer. First, compatibility. In the last few years, serial ports have almost disappeared from PCs and USB ports have replaced them. There are thousands of industrial devices that have serial ports, and the change is causing problems. Fortunately, you may buy an expensive adapter that allows you to connect a USB port to a serial device. These devices work well, however, they are only a stopgap measure. Second is speed. USB allows data to travel on an average of 10 times speed of the normal parallel port. It is also faster than a serial port. The average serial port transfer rate is 150 kilobit per second, where the USB port is up to 12 megabit per second. USB 2 is 40 times faster with a maximum transfer rate of 480 Mbps. It is backwardly compatible with USB 1. That means that if a new computer comes with USB 2, the older USB devices may still be used. Of course, they will perform at USB 1 speeds, but they will work properly. And lastly, durability. USB ports are more robust than serial ports. Serial ports are not robust. The teeny little pins are very easy to bend or break. On the other hand, USB ports are very rugged. An embedded system is a microprocessor-based computer hardware system with software that is designed to perform a dedicated function, either as an independent system or as a part of a large system. At the core is an integrated circuit designed to carry out computation for real-time operations. Based on performance and functional requirements, it is divided into four types, such as real-time embedded systems, stand-alone embedded systems, network embedded systems, and mobile embedded systems. For embedded product, communication interface can be viewed for two different perspectives. First one is device or board level communication interface that we can call onboard communication interface, and other is product level communication interface that we can call external communication interface. So what is onboard communication interface? The communication channel which interconnects the various components within an embedded product is referred as device or board level communication interface or onboard communication interface. Examples are serial interfaces like I2C, IOR, and parallel bus interface. Now, external communication interface. These are the embedded systems which may be a part of a large distributed system, and they require interaction and data transfer between various devices and submodules. The product level communication interface is responsible for data transfer between the embedded system and other devices or modules. The external communication interface can be either a wired media or a wireless media. It can be a serial or a parallel interface. Examples of external communication interface are infrared, Bluetooth, wireless LAN, radio frequency waves, etc. Embedded system security is a strategic approach for protecting software running on embedded systems from attack. An embedded system is a programmable hardware component with a minimal operating system and software. An embedded system in a smart device can be hacked to take control of everything from smart thermostats to industrial control systems. Like security in most IT fields, embedded system security requires an end-to-end approach that includes addressing security issues during the design phase. Security considerations should include the cost of an attack on an embedded system. Security features like secure boot, secure code update, data security, authentication, secure communication, protection against cyber attack, security monitoring, and device tampering detection are most important. To prevent attacks on embedded systems, software developers must need to expect firmware to be updated regularly. limit access. Secondly, to limit access to embedded systems to a need to use basis. They should provide a way for network administrators to monitor connections to and from embedded systems, and they should allow integration with third-party security management systems. Thank you everyone. Thank you.